All right, so on to the next question. Let me give a few seconds to make sure the audio is working. Let me also pop out the chat while that's going. Make sure everything is working. Everything is working. Everything is working. Yep, it's working. Everything is working. Yep, it's working. It's echoing. Okay. This should be correctly identified as max consecutive ones 3. Yeah, okay. So we'll try this one. Try this one and see how it goes. Also refresh this to. Okay, max consecutive ones 3, given a binary array nums, and in an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. So k is 2, whole bunch of ones and zeros. You could flip this one and this one to get 1, 2, 3, 4, 5, 6. Long as subarray is underlined. Here, if you could flip 10 numbers, you can get, these two, this one, these 3, and excuse me, if you could flip 3 numbers, sorry, do these 2 and this one, and then this is the longest sequence. Okay, the numbers are 100,000, either 0 or 1. It's got a pretty high acceptance rate. It's probably not that hard. Okay, so I don't have the answer yet. Let me think about it. So, let's see. Well, excuse me. You could merge the arrays for a certain cost. Cost is the difference in between the two arrays. Yeah, there's a certain cost and benefit to doing that. The idea, it's not obvious how to solve this. Probably some kind of greedy algorithm works. You could maybe do a dynamic programming solution, but I don't. Maybe. You think? How large is the value of k? K could be quite large. So you probably don't want to try something that goes over both k and n. So let's see. It's not obvious how to do this. Excuse me. I'm sure there's some kind of either linear or logarithmic, linear or linear rhythmic way of doing it. Gee, I don't know. Let me think. Think. Well. Maybe a stack works here too. Stack of pairs. So you can count the gets a little more confusing, but let's assume for a moment you can count the number of ones from left to right that you see in the first sequence. And then you say, okay, the number of zeros, I'll assume that I fill all of those zeros, right? And that's what goes on the top of the stack. we could fill all of those zeros, or none of them, right? Fill them all the way to connect to the next array. Yeah, I don't know. It's not really. Maybe some kind of heap solution? I don't know. No. Maybe sliding window is the way to go. That's probably the way to go. So you can move all the way to the right as far as you can to get as many ones in there as possible. And then you can slide the, so you move the right side all the way down, then you get to a point where you can't go any further. And then you can slide the left side down either for free or not for free, but either you move it down one spot and either gain more ones that you could place in the array, or not, right? And then you can move to the right side only when you gain, well, depending on what you see on the right side. Yeah, so you stop. Okay, I think that's the way to go. Yeah, sliding window is the way to go, definitely. 2 pointers. So I'll explain what this looks like. So we have result 0, return result. 2 pointer solution is the way to go. And we're gonna do a double loop. We're gonna increment nums of j. So how we do this is it's gonna be j minus I plus 1. All right. Oh, this is confusing. So we're going to start I and j at the same spot, and we're going to say you have 2 options, right? Nums of j is 0 or not, right? And it's going to be nums of j is 0 and k is greater than 0. And this is going to be k decrement nums of j. Then increment j. So also j is less than nums.size, always. Come back to explain exactly what this is doing. So if we see a 1 there, we can just do that. There's either 1 there, or there's a 0 there and k is greater than 0. Right? We have more values that we could expend. So if we're in the case that it's not 0, or rather 0, then we flip that to a 1 and subtract from k and increment j. Otherwise, we just increment j, right? And then we go as far as we can to the right with j, and then we update our result based off of j minus I plus 1. Yeah. This is just nums of I. Well, can we have k is 0? K could be 0. And this could, nums of I could be 0 too. What if I is 0? I could be 0. Can handle the first bit separately. I'm actually not sure what to do about that. It's a little confusing. There's a slight caveat here that makes things a little bit awkward. J should always be pointing to something that is a 1 or can be converted to a 1. I should always be pointing to a 1. Well, then in that case, you'd want to start them both at really -1 values and not include I and look at j plus 1, which is confusing. That's another way of doing things. Yeah, you don't actually know what you're starting at initially. Yeah. And then you could do it this way too, I suppose. Then you'd increment j. And so when this stops, this j plus 1, whatever value j stopped at, j plus 1 basically can't be flipped. What you would eventually want to do is, now this makes it so confusing, let's not do that. Let's try to start them off at index 0 and 0. I mean, that's the thing, is that I want whatever j is at to be, oh man, this is so confusing. Why is it so hard? No. All right, it's not that easy of a question, I guess. I gotta really think about it. So, yeah, I mean, so yeah, you flip as many as you can on, and it's j minus I. It's not j minus I plus 1, because I could be itself not a 1, right? And in fact, if j and I are both 0, if this just immediately stops, then you'd return 0, right? So we didn't process I yet, right? And then we would say, here we want to increment I. And more importantly, so if nums of I, and obviously I is less than or equal to j, and I is less than j, right? Nums of I and I is less than j. So it's actually, it's not nums, yeah. So the way it's going to be is k plus equals this, and then increment I. And that's very confusing. But basically, what it means is that this value is 0. If it's less than j, we're gonna flip. It got flipped to a 1 when j went through it. If it's 1, then it didn't get flipped, right? So we don't need, we don't gain a new value for k. So when we move through it, if it's a 1, we're not going to increment value of k. If it's a 0, then we are going to increment the value of k. This only happens when we actually move through it. In other words, if it was 0 and we didn't have enough values to move through 0, I is not less than j, then we would just increment. And then we also say j equals the maximum of I and j, right? If, in other words, I could start moving past j also. And if I moves past j, we want to update j to I as well. So something like this, I think, should work. A little bit complicated, but it's along these lines. Also I is less than nums.size. Forgot about that. Important condition there. There we go. All right, so let's see if this works for other cases. Let's try some unusual things. 0, 1. Let's use the numlock. Nope, that doesn't work. I don't know, I'm trying to, gotta do this kind of carefully. Okay. Something like, oops. Something like this. And try just a few different things. I'll try a 1, a 0, a few zeros, a few 1s. It's better if you could just prove things. 0, 1, 0, 0, 0, 0, 1, 0, 1, 1, something like this. It's kind of tricky cases around the smaller value. Yeah, it works for all this. Okay. I think this is correct. I'm tempted to just go for it. I'm not really sure what I want to do exactly. All right, let's just try that. And then I think I'm going to go for it. I didn't prove that this is correct. I think it's correct, but I didn't prove it. That's fine. Doesn't have to prove everything. Yep, got it. Sweet. Very good. So kind of slow, actually, which is disappointing. I wasn't expecting that. This is like linear time solution. This is a fairly efficient solution. Surprised that it's so slow. Submit it 5 times, then move on to the next one. It's linear time. That's sort of good enough. It doesn't have to be the fastest thing ever. Yeah, a little bit disappointing though. Disappointed. Why is it so slow? Oh. Huh. That's sad. That sucks. 1, 2, 3, 4, 5. I'm just sitting here wondering, why is it so slow? It doesn't have any if statements at all either. I don't know if I need this, by the way. Is J always going to be to the right of I? No. Yeah, as soon as you have C as 0, I mean, you could do, yeah, I mean, I don't know. I don't know what to say here with this if statement. Kind of disappointed. It's so slow. Why is it so slow? Dang. I don't know. Oh, okay, a little faster that time. Yeah, I don't know. I mean, all right. I don't know. Man, I don't know. All right. Yeah, it's just, sometimes it's not that fast. Okay. All right. Anyway, whatever. Whatever. There's maybe a better way to do this. That's still linear time and a little bit faster. I don't know what to say. Okay. I'm not gonna bother trying to figure that out. It's not that important. Okay. So thanks for watching. If you like the video, like it and subscribe. I'm going to stop here. No, not stop here, but go to the next question. Go right to the next question. So, what are we doing on time? Yeah, okay. Now we'll go to the next question here.